finding the greatest common factor. So yesterday we worked on finding least common multiple, and we said that there is no greatest common multiple because multiples go on and on and on forever. With factors, though, there's only a certain number of factors for each number. And when we were talking about our prime and composite numbers, we proved this. So some numbers, prime numbers, only have two factors. Some numbers, composite numbers, will have two or more factors. There's not really an infinite number of factors, but each number has a certain amount of factors. So we're going to look for the greatest common factor. Today, our essential question, just like we start out with, is what is the greatest common factor of two numbers? By the end of the day, our goal is that we should be able to find the greatest common factor, or the GCF, of two or more numbers. Now, if you need to find the GCF, or the LCM, of more than two numbers, you just apply the same strategies to the third number, and then compare. So here we go. Let's talk about what is this finding GCF. And we're going to break it down into each part just like we did yesterday with LCM. So our G, that G stands for greatest. And greatest just means the largest value. The C stands for common, which, just like we learned yesterday, means the same. And the F now stands for factor. And factor is one of two numbers that when you multiply them together, they create another number. Or it's a number that a target number is divisible by. So we're going to use that kind of term when we simplify what greatest common factor is, when we say it's the largest shared divisible by number. This time, we actually have three different ways of finding GCF. We have list and compare, which we had with LCM. We had prime factor cake, which we had with LCM. And we had the prime factor trees, which you can actually do with LCM, but I find the factor trees with LCM much more difficult. So that's why I didn't show it to you. When you get into middle school and high school and we start factoring polynomials, we use the cake method or the continued division method. So that's why I like to show the cake method, but I also like to show that you can do this with the factor tree. So let's get rid of these two because we don't need them, and let's focus on just list and compare for right now. So when we list and compare, let's say we had 56 and 42, we're quite literally going to list out the factors of 56. Remember, I like to use a table. Some of you like to use the rainbow, and that's fine. So I'm going to start listing them out. My first is 1 and 56. Every number has 1 and itself. Those are called prime numbers if that's their only factors. Then I start listing down the counting numbers on the side here and deciding, is this number 56 divisible by this number? So 2, yes. 56 is divisible by 2, and it is 16. I'm sorry, 18. I'm sorry, 28. Typo, 28. Is 4? Yes, 14. And how about 7? Yes, 8. Now let's do 42. Same thing. 1 and 42. 2 and 21, 3 and 14, and 6 and 7. Okay? Now I'm going to start comparing. Well, they both have 1. They both have 2. They both have 7. And they both have 14. So what's my greatest common? What's the biggest value that they have in common? 14. The greatest common factor of 42 is 14. Okay. That's easy. What if I start getting a little bit harder numbers? Not like terribly hard numbers, but a little bit harder numbers. This is where that factor tree or prime factor cake are going to be a little bit more helpful. So with the prime factor cake, let's look at 64 and 100. And again, what we're going to do is we are going to divide each one. We're going to do it upside down, but we're going to divide each one by a prime number. And I noticed that both of these are even, so that's the easiest one to divide them by. I'm going to do it by 2. When I take 64 and divide it by 2, I get 32. And when I take 100 and divide it by 2, I get 50. These are not prime numbers, so I'm going to keep going. They're both even again, so I'm going to divide both again by 2. 32 divided by 2 is 16, and 50 divided by 2 is 25. Now I am stuck. I cannot think of a prime number that goes into both 16 and 25. The only numbers that I can think of that go into 16 are 1, 2, 4, 8, and 16. But none of those numbers go into 25 as well. So now I'm done. I'm actually just going to cross these out so I don't even think about them because I just need to focus on these 2 over here on the outside of my cake, or the frosting on my cake, for whatever, if you want to call it that. Then I'm just going to multiply those 2 together, or however many are on the outside of your cake together, and I get 4. Guess what, guys? The GCF of 64 and 100 is 4. Let's try one more method. Let's try these prime factor trees. I have been told that you learned prime factor trees last year if you attended Central Park. I have been told this. So we're going to give it a go and we're going to try it. So with prime factor trees, now this time I have 36 and 108. You also have those on your notes. And what we're going to do is we're going to break up 36 using multiplication. So I'm going to pick a prime number that I know goes into 36, and then I'm going to say, okay, what times that prime number equals 36? So let's start with 3, because I know that 36 and 3, 36 is divisible by 3. In fact, 36 is divisible by 3 12 times. So I'm going to put that 12 there. I circled 3 because it's a prime number. 12. I have 2, I have 3. I'm going to go with 3. And 12 is divisible by 3, and 3 goes into 12 4 times. Okay. Circled 3. Prime, 4 is not, but 4, when I break down 4 using multiplication, I get 2 times 2, and 2 and 2 are prime. Let's go over and do 108. So I'm going to split it up with multiplication again, and I'm going to choose 2 because I don't honestly, off the top of my head, know any other number. I know that it's even, so I'm just going to divide it by 2 and get 54. Split up 54. And 54, I'm going to go with 2 again. I don't know any other numbers off the top of my head, and I know that I can get 27. 27, not divisible by 2. It is divisible by 3, though. 3 goes into 27 9 times. 3 is still prime, 9 is not. But I can split up 9 using multiplication with 3 times 3. Okay. Now what I want to do is I want to look for this, and I'm going to compare these 2 trees, and I'm going to look for factors that they have in common. So do you notice that each one has a 3, each one has a 2, and each one has another 3, and each one has another 2. Each tree has 2 3s and 2 2s on it. The second tree has a third 3 on it, but we don't need to worry about that third 3. So now what I'm going to do is I'm just going to multiply all of those together, and I'm going to get 2 times 2 times 3 times 3. 2 times 2 is 4. 3 times 3 is 9. 4 times 9 is 36. So the greatest common factor of 36 and 108 is 36. Are you ready to try it? Here we go. You have 48 and 72. I'd like for you to pause it right now and solve this problem on your notes. Pause it and come back and check your work. Welcome back. Did you get what I got? I got a final answer of 24. If you didn't get 24, I want you to pause it again and look through one of the 3 methods that I did to see where you might have gone wrong. If you did, congratulations. If you're still struggling, make sure that you tell your teacher. Let us know if you need anything. Otherwise, do not forget to do your seesaw work. Have a great day, guys.